simplifying variable expressions. We've learned all of the, well, I should say, there are going to be some we're going to use today. We've learned all of the rules, the properties, but there are going to be a couple we're going to use that they also are assuming you came to Algebra 1 already knowing, okay? And we're going to use those almost right away here. So number 1, we have that 4 in the crook of a radical sign, and under the radical sign, what's called our radicand, we have x to the 4th, y to the 12th. So what is this really asking us to find? What is it asking us for? Isaiah?
The 4th root of x to the 4th power divided.
Yeah, it's asking us to find the 4th root of that algebraic expression, x to the 4th, y to the 12th. So let's write that as a fraction power and get rid of that radical sign. So let's first take this and rewrite it as something, the x to the 4th, y to the 12th, to a rational power. So if we're trying to find the 4th root, that's the same as taking it to what power?
1/4.
The 1/4 power. So finding the 4th root of something, like they showed it with the radical sign and the index, is the same as taking it to the 1/4 power. So Ricky?
Could you just multiply all the exponents?
Okay, well here's what we have to do first of all. We have what's called a product going on inside of these parentheses. In other words, our base is a product. X to the 4th, y to the 12th is a product. What are the two factors involved in that? X to the 4th, y to the 12th.
Exponents multiplication.
So when you have first of all, the first property, which we haven't really used yet, they're assuming you knew before you got here though, is when you have a product to a power, each of those factors gets that power. So first thing we're going to do is we're going to take this and we're going to give the x to the 4th its own 1/4 power. And we're going to give the y to the 12th, remember it's a product, x to the 4th times y to the 12th. We're giving each factor their own power of 1/4. Because they don't have the same base. So we're going to let them work independent of each other. Well, now we have a power to a power times another power to a power. Now, this is something that we did last week. What happens when you're taking a power to a power? What do you do to simplify that? Christian?
Multiply
You multiply them. What's them?
the powers.
The powers. So we're going to take x, and we're going to take that 4 times the other power, 1/4. And then, same thing with the y's. It's a power to a power, so to get rid of the power to a power, we say I can take the exponents times each other. Now you need to stay tuned in every moment today because this stuff is tricky. Okay? X to the 4 times 1/4. What is 4 times 1/4?
3.
1.
1. 1/4 of 4
I thought I was doing it.
is 1. So this becomes x to the 1st power times y to the, what is 1/4 times 12?
3.
Or 12 times 1/4, or 1/4 of 12, and you're right, it is 3. Michaela?
Do we have to put the 1 over the x, or can we just put x?
Do you have to put it next to the 1st power, you mean, not over the x, but to the 1st power? For now you do, and then we'll clean this up, okay? So yeah, let's put that x to the 1st power to show that 4 times 1/4 is 1. And now we'll clean this up and say our answer is going to be, we don't need the multiplication symbol, we don't need that one that Michaela was just talking about. They are different bases, so we can't really multiply them and do the property that says add their exponents because they're not the same base. So what would this look like in an answer bank? Carly?
X, y to the 3rd.
xy to the 3rd, yeah. That's how we would see it in an answer bank. We can eliminate that multiplication dot, we can eliminate that 1st power on the x. And are there any negative exponents involved?
No.
0 exponents?
Mhm.
No. Anything else we can divide out? No, we don't stop until we're sure that it is simplified as much as it can be. So we have our simplified answer, x, y to the 3rd power, with only the y being taken to the 3rd power, right? If it meant xy to the 3rd power, both of them to the third power, what would the x and the y have to be? Ricky?
In parentheses.
In parentheses, yeah. Okay. Anybody have any questions about that one? Any parts of that that didn't make sense you want to go back to? Okay, let's go to this next one then, where we're going to, the first thing we're going to do is we're going to just take the numerator and we're going to rename it. In other words, we have a power to a power, but first of all, we got a product to a power. We have an x times a y to the 1/2 power. That's a product. There's a multiplication going on there. So when there's a multiplication going on, we're going to give each of them their own power of 2. So this is x, it's going to get its own power of 2. Y to the 1/2 power is going to get its own power of 2. So a product to a power, give each of the factors their own power. X is a factor, y to the 1/2 is a factor, over, how could we write the denominator as a power? How could we write that one as a power? Ricky?
That would be x to the 5th in parentheses times to the 1/5 power.
To the 1/5 power. X to the 5th power, what's underneath the radical sign, the radicand, to the 1/5 power. Okay, now we'll just do some x to the 2nd power, x to the 2nd power, right?
Y to the 1st.
Y to the, what do we do with these? We multiply them. Let's show that in our notes. So when we look back at our notes, we can say this is what we actually did to get there, okay? Y to the 1/2 times 2, because a power to a power, we multiply their exponents. And downstairs, it's a power to a power again, so we're going to do x to the 5 times 1/5. So a power to a power, multiply their exponents. We're just showing that we're multiplying the exponents. What we didn't show in this one is this is really x to the 1st power. And x to the 1st power could be it could be 1 times 2, couldn't it? We just didn't show that one. Okay, what does x to the 1 times 2 power become? X squared? How about y to the 1/2 times 2 power?
X to the 1st, or y to the 1st.
Y to the 1st, because half of 2 is 1. What's 5 times 1/5? Or 1/5 of 5? 1. Okay, so now we have x squared times y to the 1st over x to the 1st. What do you think we could do now? What do you do now? Morgan, what do you think?
You divide the exponents of x.
Yeah, because there was no addition or subtraction going on upstairs. And that's what allows us to do it. There cannot be any addition or subtraction going on. And since there is no addition or subtraction going on, we can really now just take these x's and divide them. So do you remember what we do when we do dividing? With the same base, what do? You subtract. So it's x to the 2 minus 1 power, and that y to the 1st is upstairs, so we'll just leave it y to the 1st. So what do we end up with? X to the 2 minus 1 power becomes what?
X to the 1st.
X to the 1st power. And y to the 1st is y to the 1st. And now we'll clean it up. Cleaned up, our answer will be
XY.
xy. We do not need our exponents of 1. We do not need our multiplication dot. Our answer is xy.
And it's in order.
And it's in alphabetical order. Who's that? Okay. Questions on that one at all? Okay, all I want you to do is on number 3, I want you to get it started on your own. I want you to take that numerator, and I don't want you to do too many steps in one. These are your notes. I want you to show every step of the process. So I want you to rename that numerator. What can you do to get this problem started out? Rename that denominator. What can you do to get it started out? what you should have been able to do. It's a power to a power upstairs. We multiply their exponents. We're going to take that radical form and rewrite it as a power. When there's not a number in the crook of the radical sign, we know it's an invisible 2, don't we? When they don't write 1 there, it means square root, it means index 2, root 2. Okay? So what does the numerator become? Z to the first power. What do we have to do downstairs? We have to multiply 2 times 1/2, so it's Z to the 2 times 1/2 power. Notice we're being very, making sure we show everything that we actually do. Every process that goes through our head, we're writing down so we can follow it. So Z to the first, we'll just leave that Z to the first for right now. What does our denominator become? Z to the first. Okay, there's 2 ways to go about this. This is the same base Z. When you divide, you subtract the exponents. 1 take away 1 is?
0.
0. 0 to Z to the 0 power is? 1. Or you could say to yourself, anything divided by itself is 1. So this does equal 1. Only when that Z to the first is not 1. It's 0, right? You can't divide 0 by itself. Nor can we take 0 to the 0 power. But we're always going to assume that Z, our variables are not 0. Morgan?
Okay, so if you have like 2Z to the first power and 4Z to the first power, is that like?
So here's what I'm hearing. Is that what you're saying? Okay. What would happen with these guys? Now we got a multiplication upstairs and a multiplication down. So whenever there's multiplication, we can just cancel, right? Do these guys cancel each other out?
Yes.
Yeah. Yeah. And 2 over 4 is what we have left. What does that simplify to? 1/2. Then our answer would be 1/2 instead. Okay? That make sense? Okay. Anybody else? So that was just a what if that Morgan was asking. What if there was a 2 in front of the upstairs, Z to the first, and a 4 to the downstairs? Okay, then let's go on to this last one. This looks like number 2. What would be the first thing we would do in this one? We have a product to a power, right? So we're going to go A to the what? A to the second raised to the fourth. A to the second raised to the fourth. It gets its own power of 4. Times B to the 1/2 raised to the 4th. How can we rewrite the downstairs? Isaiah?
You can do B to the second in parentheses raised to the 1/2.
Yeah. That's really B squared raised to the 1/2 power. Whenever there's a radical sign, no index written there, we know the index is 2. We know the root is 2. Okay, so now A to the second raised to the 4th, we do A to the what? 2 times 4. And here we're going to do B to the 1/2 times 4. And downstairs we're going to do B to the 2 times 1/2. Seems like a lot of writing and a lot of steps to go through, but if you take your time and do it this specifically, you will probably be more successful. Okay? So now we're to this. We have A to the 2 times 4 power. What is that? Riley? A to the 8th. Okay. B to the 1/2 times 4 power, class. That's B to the second. 2/2 of 4 is 2. Downstairs we have B to the 2 times 1/2, B to the first power. Okay. Do we have any addition or subtraction going on upstairs?
No.
No. So when we don't, can we divide like bases like this? Okay. So this A to the 8th is going to stay upstairs because it's got a positive power. No sense to mess with it. Leave it alone. And we're going to now have times B to the 2 minus 1 power, when we're dividing. And that's going to become a to the 8th times b to the what power? First power. Cleaned up, our answer is
A to the 8th b.
a to the 8th b. No negative exponents, no zero exponents. Can't divide anything out that will help us out, so I would say we've got it simplified, right? Okay, that is taking and simplifying an algebraic expression. And what we're going to do on the back is a little bit different again now, so let's make sure you don't have any questions on any of this front stuff, the ones we did on the front side. Any part of that we need to go back to. Okay, well, let's go to the back side and see what's going to happen. We're going to be taking a fraction to a fraction power, which should not be scary at all because there's another property that they assumed you knew when you got to me this year. And that was, if you have a fraction being taken to a power, you can give the numerator that power, and you can give the denominator that power.
Whoa.
So we're going to rewrite this as 8 to the 1/3 power and 27 to the 1/3 power.
Of over 27.
So the numerator got the power, the denominator got the power. Just like on the multiplication, when we were doing on the front side, we had a multiplication, we gave each factor the power. Here we have a division, we're giving each part of the division problem the power. Now this is really asking us, up here, this one's asking us what times what times what equals 8, right? Isn't that what that's asking? 8 to the 1/3 power? What is it? 2, okay? And this one down here is asking us what times what equals 27. That's 3, right? 3 times 3 times 3 is 27. So we really just found out that we have 2/3. 2/3 is our, what's going to be multiplied by itself 3 times to get 8 27s. There's a reminder, 8 over 27 to the 1/3 power means what times itself 3 times is 8 27s. Would, so let's check. We say that 8 over 27 to the 1/3 power, we just decided it is 2/3. Right? Isn't that what we just decided? So in other words, that means then, if we took 2/3 times 2/3 times 2/3, it better get us back to 8 27s. Would it?
Yes.
2 times 2 times 2, 8. 3 times 3 times 3, 27. It does. So 8 over 27 to the 1/3 power, that fraction to the 1/3 power is 2/3. Okay, that's when the numerator was 1 for our fractional exponent. So our 1/3, the numerator was 1. Remember on Friday, when the numerator wasn't 1, we had to do a little extra, sideline. We had to decide then, what does this really tell us? In other words, it can be written as a power to a power. So what would that power be? That power to a power be that we could write 4 over 49 to what power first of all? Morgan? No. 9? The 1/2 power. The denominator. So when we're rewriting this as a power to a power, we have 4 over 49 to the 1/2 power. We're going to have to use another type of grouping somewhere. We're going to use a bracket to show now that whatever we get for that answer, 4 over 49 to the 1/2 power, we're going to have to take that to what power?
3.
To the 3, the numerator power. So, what times itself twice is 449s. That's the first thing we're going to look for. What times itself twice is 449s, and that cubed. So let's look for the square root, in other words. words, of 449s. So remember how they can each have their own power of 1/2. So what we're looking for here is what times itself is 4, what times itself is 49. Riley?
2 and then some.
Okay, 2 times 2 is 4, or in other words, 4 to the 1/2 power, or the square root of 4 is 2. 7 times 7 is 49, or in other words, 49 to the 1/2 power, or the square root of 49 is 7. So now we are saying that this becomes 2 sevenths. That's just this part, you guys. So we just replaced this part with 2 sevenths. We still have the brackets and the to the third power. So we found the 4 over 49 to the 1/2 power. Now we found that to be 2 sevenths. So now we have to take that 2 sevenths and cube it, take it to the 3rd power. So we're going to do 2 to the 3rd power. The numerator can have it. The denominator can have that 3rd power. Or you can think of it like this. You're taking 2 sevenths times 2 sevenths times 2 sevenths. What is 2 to the 3rd power? No, 8.
8.
What is 7 to the 3rd power? Remember, we don't use calculators.
Oh no.
7 times 7 is
49.
49. 49 times 7.
Oh.
Let's jump up to 50, just one unit away. 50 times 7 is
300.
350, but we went up 7 times, so we gotta take 7 away.
147.
343.
100.
343. Okay. So our final answer is 8 over 343.
That's.
You
can use it.
Now, well, you can. There's no way for me to stop you, right? But will it help you when it comes to the quiz?
No.
No. So here, listen to me on this though, because you always have to give your answer simplified. So do you think 8 over 343 could be simplified some more? Is there something that divides into 8 that also divides into 343?
No,
How do you?
because it's 7 to the power.
One's odd and one's even, so that means if you have an odd number and an even number, it will never. How about 9 and 24? One's odd, one's even.
8 times 8.
What are all the numbers that divide into 8? Other than 1, 2
2.
and 4, and 8 of course itself. So you'd have to see if 2 goes into 343, and I don't think it does because it's odd, right?
Yep.
Okay, how about 4?
No,
How do you know? Have you tried?
because it's not on.
Oh, because it's odd, so there are no
Okay.
multiples of 4 that are odd? Is that what you're saying?
4.
Whether you see it's number 4 was odd.
There's 1 times 4.
Okay, let me give you a little hint. Here's what you always want to do. Before you actually take this to a power here, make sure this is simplified. This is a much easier number to decide if it's simplified than that one. Is 2 sevenths simplified?
Yeah.
Okay, if that's simplified, your final answer will be simplified also. Okay? So check it out here before you have to get to there to 8 over 343 and then not be sure. Okay? Okay, now we're going to try that again. You go ahead and do the first setup. Get started on this one. Rename it as a power to a power underneath it. Rename it as a power to a power. That's our first step. And when you think you have it named as a power to a power, check yourself out.
Yes.
Smart board. Because the smart board is smart. So
Well, technically the board does nothing, but
technically, that's
computer
true.
does everything else.
Well,
Technology.
I don't think it's
The teacher does a lot too.
Okay, so we agree on
I
this?
can say that.
We agree this is the power to a power name for it?
Yes.
Okay, so the first thing we're going to do is we're going to take that 8 over 125 to the 1/3 power. That's our only goal right now, and give each of them their own power of 1/3. We're just gonna simplify that right now. What is 8 over 125 to the 1/3 power, in other words? So, we are looking for something that times itself 3 times equals 8,
2.
and, okay, 2. And something that 3 times itself is 125, and that's 5, you say, okay.
Simplify.
So we just found out that the 8 over 125 to the 1/3 power equals what? 2/5. Okay, so this became, what was inside the brackets became 2/5.
Simplified.
So let's ask ourselves this question, is 2/5 simplified?
Yes.
Okay, so then that means when we get our final answer, we shouldn't have to worry, right? Okay, so this is gonna be 2 to the 4th power over 5 to the 4th power. 2 times 2 times 2 times 2 is?
16.
16. 5 times 5 times 5 times 5 is?
625.
625.
I'd steal
And the answer is 16 over 625. Is it simplified?
Always had to be the shift.
Yes, it is. We're convinced it is. Okay.
Are those real?
Dollar, don't change it.
Okay, I'm just gonna stop the recording is what I want to do, but I won't get it. Get out your little slip of paper, view of the notes. If you're done with the notes, get out your little slip of paper, get the heading put down. And yes, it is evens in all 3 sets, so 24 through 30, just the evens. 52 through 58, just the evens. 68 through 80, just the evens.
Yeah.
And will I accept decimal answers?
No.
No.
Absolutely
My
not.
darn
Ever, ever,
calculator,
ever, no.
it just loves to give decimal answers. But since the calculator is not our buddy right now in this lesson,
Almost calculators is a button that will change it from decimal to
I know there are calculators that do that for you too. I think they just think all the time for you.